Good evening, everybody. Let me know if you can hear me. Thank you. Thank you for your response. Okay, so today, on Tuesday, we went over how to measure the center of a data set. And today, we are going to learn how to measure the variation of a data set. And what is the variation of a data set? Variation is also a measurement. It measures or describes how spread out the data values are around the center of the data set. So that's the definition for variation. Variation describes how spread out the data is around the center of the data set. Let's look at this diagram. Let's look at this graph. We have two dot plots. In this graph, we have two dot plots. Two dot plots. Okay, yeah. So the yellow one on the top, that's the first one, and the orange one on the bottom, that's the second data plot. There are two different graphs corresponding to two different situations, right? So when you go to the bank, like a physical bank branch, and many times you have to wait, right? In the yellow one, we have 25 participants. The researcher recorded the waiting time of those 25 participants if the waiting line is single. There's one line. And the orange, the one on the bottom, also has 25 participants. In this case, the researcher recorded the waiting time of the 25 participants when they are waiting in multiple lines. So it turns out the two distributions of the two data sets have the same center. Let me write it down. They have the same center. All right, yeah, we covered the center on Tuesday. However, the two data plots very different, right? Do you see what's the difference? What part of the two data plots is different? Center is the same. Yeah, the distribution is different. In the single line case, all the data is scattered very closely, scattered around the center, right? This is the center. This is the center. In the second graph, in the case of multiple lines, those data values spread away, wider, away from the center, right? That's the difference. So here we want to consider a question. If you are a customer, would you like to wait in a single line, or would you like to wait in multiple lines for the service in a bank? Based on the information, based on the two graphs we have here, the average waiting time is the same. Statistically, average waiting time is the same. However, the single line case, the waiting time is more consistent. Yeah, you know, either I wait, the minimum waiting time is around 98, and the maximum waiting time is 102 seconds. Yeah, very consistent. Consistency is better. And in the second case, even the average waiting time is the same, but sometimes I might only need to wait 85 seconds, but next time probably I have to wait like almost 2 minutes, right? So as a customer, would you like the bank to adopt a single line or multiple lines? Think about two companies providing the same products, same type of products. The first company, yeah, the average speaking, the quality is similar. But the first company, the quality is very consistent. Yeah, you know you will not get a very bad ones. But the second company sometimes give you good ones, sometimes give very good ones, sometimes give you really bad ones. So would you choose the first company or second company? Similar with our situation here, right? Let's see. Yeah, most of you would like to choose the single. Dustin like to choose multiple. Can you explain why? Why would you like to choose the multiple lines? Less consistency.
Yeah, I think it's more of the fact that, it's kind of like gambling. You might have a chance of getting in quicker, but at the same time, you might lose time. So it's kind of,
You
which
like
one?
risky.
Yeah.
You like, okay, I got you. I got you. Yeah, everybody could have a different preference. That's perfectly fine. I think if we consider majority people's opinion, subjective opinion, they would prefer single line service because it's more consistent. Yeah. In another example that I give you, the first company, the quality, the variation of the quality is very small. Yeah, you know you will not get a too bad. If you will not get a too good, but it's the you will get what you expected. But the second company, the variation is very large. Sometimes you might get more than you want. Sometimes you might get a lot worse than what you expect. So you might get pissed off, right? So majority of people, I think, would like the one with more consistent services. Okay, yeah, so let's read this part. The single line / multiple line illustration is wonderful because banks actually did change from multiple lines to a single line, not because it made them more efficient, not because the customer waiting times were reduced, averagely speaking, but because customers are happier with waiting times with less variation, more consistent. Yes, if you are waiting there for a very long time and witnessing other customers get it done very quickly, you are not happy, right? But if you know everybody, have similar waiting time, then you're probably happier that way. Yeah, the change did not affect the merits of center, but banks instituted the change to reduce variation. An important goal of business, let me highlight this part. An important goal of business and in industry is this: improve quality by reducing variation. Make your service more consistent. More consistent. Do you get the point from this example? Yeah. Do you understand what is a variation? Is that clear? What does variation describe about a data set? And if the variation is a measurement of the service, quality of service, and we want the variation as little as possible. Okay, that's what we need to know about from this example. Okay, so today, excuse me, we are going to learn 3 types of measures of variation. Yeah, very similar with on Tuesday. On Tuesday, we learned measures of center. We had 4 different measures of center. And today we measure another different statistic. It's called variation. And we're going to learn 3 different types of measures of variation. The first one is range. Yeah, again, variation measures how the data spread out from the center, right? Yeah. So the first one is called a range. The formula for finding range is maximum minus minimum. Since when we find the value of a range, we only use the maximum value and the minimum value from the data set. Yeah, those could be outliers or extreme values. This statistic range is not resistant. What is not resistant? Not resistant means this measurement, way of measure, is very sensitive to outliers. Very sensitive to outliers. So that is a disadvantage. That is a disadvantage. But we use range a lot, right? Yeah, so let's say the scores of your test 1 of this class. Yeah, sometimes we would consider what's the range of the scores of your guys' scores for test 1, right? I would use the highest score to minus the lowest score, and that's the range. That makes perfect sense, right? Yeah, this one is the simplest way to measure variation. It's simple, but it has a disadvantage because it's very sensitive to outliers. If you have outliers in the data set, you probably shouldn't use this type of measure of variation. Okay, so the second measure of variation is a sample variance. Sample variance. The notation for sample variance is S-square. When we talk about sample variance, we need to know a similar concept is called a population variance. The notation for population variance is sigma square. And the notation for sample variance is S square. Okay? Yeah. Do you still remember parameter and statistic? Parameter is a numerical description of the population. Statistic is a numerical description of a sample. Yeah, so parameter corresponds to population. Statistic corresponds to sample. And they both are called variance, but sigma square is the variance of population. S square is the variance of sample. So which one is the parameter? Which one is the statistic? Yeah, exactly. Thank you, Melinda. Yeah, parameter, it corresponds to population. So sigma square is a parameter. S square is a statistic, singular. And normally our goal is to know the value of sigma square. But for some reason, when the population is very large, it's really hard to know the exact value of sigma square. So we have to estimate or approximate. And S square is the estimation of sigma square. Okay, so S square variance is used as an estimator of sigma square. Sigma square is our ultimate goal. In the case that it's not possible or very difficult to know the exact value of sigma square, we use sample variance S square to estimate sigma square. So that's the second measure of variation is called a variance. That's how do I pronounce it? Always right. Variance. Yeah. Okay, let's look at the formula of variance. Notation again, S square equals is a quotient, has numerator, has denominator. Yeah, we are talking about here right now. The numerator is the sum. Sum of what? Sum of squares. Squares of what? Yeah, so what happened is, in order to find the sample variance, we have to find the sample mean first, the center. And then we are going to find out, and then we are going to use each value in the data set to minus x bar. So x of 1 minus x bar, x of 2, yeah, the second value minus x bar, and the third value minus x bar, the nth value minus x bar. Yeah, we use all the values, each single value in the data set to minus the mean. And then we square the deviation. Yeah, those are called deviation, by the way. You use the data value to minus mean. The difference is deviation. And then we square those deviation. Why do we need to square the deviation? Because sometimes the deviation is positive, sometimes the deviation is negative. So we want to add them up. So we do not want the sign to distort the variation. So we have to remove that effect. One way to do that is to square. And then we are going to add them all up. Add them all up. And that's the numerator. That's the numerator. And then we're going to divide the sum by n minus 1. N is the sample size, or the total number of values in the sample. We use n minus 1 is because if we use n for the denominator, then the estimator, then S squared would be a biased estimator of sigma squared, or S squared will be underestimate the actual value of sigma squared. So here, statistician did a correction. Instead of use n for the denominator, we use n minus 1 as the denominator. Also, n minus 1 is the freedom of degree. Yeah, we have a detailed thing to talk about that on page 104. If you are interested in to know why the denominator is n minus 1 instead of n, please go to the textbook and read that part. For us, our focus is to understand the concept and know how to compute the value of those measurements. Do you think the formula of the variance, sample variance, makes sense? Do you think the formula, the value computed by using the formula, does describe the variation? Firstly, it includes all the values in the data set, right? All the values are included. We use each single value to minus the mean. Those are deviations. Deviations describe how they, spread away from the center. The square here is to remove the effect of the sign. And then we take the sum, means we consider all of them. We consider all those deviations. And then we take the average, not exact average. We use n minus 1 as the corrected denominator. So do you think this formula would give us something that does describe the variation of the data values of the data set? Yes or no?
Yes, I believe so, but I'm interested in seeing an example.
Oh, yeah, I will. Yeah. Yeah, sometimes I elaborate this too much, right? Okay. The next one, the last measure of variation is called the sample standard deviation. The notation is S, lowercase s. And sample standard deviation, little s, is the estimator of the population standard deviation, sigma. So here, S is a statistic, sigma is a parameter. S is used to estimate the value of sigma. And from the notation, you can see the sample variance is S squared, sample standard deviation is S. So S squared, S. So that means the sample variance is the square of the sample standard deviation, right? It's same with the population variance and the population standard deviation. Population variance is the square of the population standard deviation. Yeah, that's the relationship between those two measures of variation. the variance is the square of the standard deviation, and the standard deviation is the square root, principal square root of the variance. Okay, yeah, so we only need to remember standard deviation is the principal square root. Principal square root means is positive. It's not going to be negative, okay? Never be negative. Square root of the sample variance. Properties about the sample standard deviation is not unbiased. Unfortunately, is biased. Then why do we use it? Because S squared is good, but S squared does not have the same unit with the values in the data set because it's a square, right? So in order to fix that, we take the square root. The square root is to cancel, is to reverse the effect, kind of reverse the effect of the square. So we have S have the same unit with X. Yeah, those are related to your homework, by the way. They do those features related to your homework. They sometimes ask you the unit of S and then ask you unit of S squared. You're going to know S has the same unit with the values in the data set, but the unit of S squared is going to be the square of the unit of the data value in the data set. Okay, now let's look at questions. Example 1. This is a data set. How many values in the data set? What's the sample size? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 10. Okay, so we have a sample of size 10. We are going to compute the range of the data set, the standard deviation of the data set, and the sample variance of the data set. You guys ready? In the first part, we are going to find the range, right? Range. Do you remember the formula for range? Maximum minus minimum. Yeah, look at the data set. What's the maximum? What's the biggest value? 41. Awesome. What's the smallest value? I think it's sorted, isn't it? I think, yeah, it's sorted, so it's good. It's sorted. So minimum minimum value is 10.7, right? Okay. And what's the difference between the maximum and the minimum? $30.3, am I right? Yeah, 3010 is 40. 0.7.3 is 1. Yeah. So the range is 30.3. Yeah, very straightforward, this problem, this part. And second part, we are going to find out what is the sample standard deviation. Please know how to say the name of S. Know the notation, also know the name of the measurement. It's called a sample standard deviation. We have a process of finding the sample standard deviation. I'm going to apply this process. It has 6 steps, okay? Yeah. Normally, I would recommend that you make a table on your scratch paper, okay? Yeah. Firstly, I need to find the sample mean. Yeah, whenever you need to find a sample standard deviation, you need to find the sample mean first. Do you have the calculator ready? How do we find a sample mean, by the way? We learned on Tuesday. 41 plus 40 plus 39 plus 32 plus 23 plus 19 plus 16, 12, 11.5, 10.7. My sum is 244.2, and then divide by 10. I have 24.42. That is my center, sample mean. Yeah, exactly. Thank you, Leah. So that's the first thing. We find the sample mean. And then I'm going to do this. I'm going to find the deviation. I'm making a table. In the first column is deviation, okay? Yeah, I'm going to have the each single value minus the sample mean. 41, 40. Of course, Excel would do this faster. Static crunch even faster, but same with the first section of this chapter. We do not recommend you to use those software because you will not have a software to use when you take the test. So when you practice, I'd like you to use your calculator only. And then 32. And only when you manually calculate it, you know the process, you know the concept of the standard deviation. 32, 23, 19, 16, 12, 11.5, 10.7. Ask me if you don't know what I'm doing here, okay? So the first thing, we find the sample mean. We got it already here. Second thing we do, we are going to use each single value in the data set. We have 10 values in total. Use each of those values to minus sample mean. Oops. What's that? 42 minus 24.42. Yeah, let's see what is the difference. And then second column, I'm going to do the square of the deviations. Deviation square, okay? So this is the table. So I'm using my calculator. 41 minus 24.42. The difference is positive 16.58. And then raised to the power of 2, we have 274.8964. We're going to do that for each single row. Yeah, be patient. And then 40 minus 24.42. We have 15.58. That's the distance between the second value and the center. That is the second deviation. And we raise that to the power of 2. We have 242.7364. Okay, you can do that in your own pace. I'm gonna be silent in case I don't want to really disturb you. So let's do that together. I'd rather take my time, not rush, than making any mistake. Even just tiny mistake, I don't get the answer right. Let me know if any number you got is different from mine. Not too bad, right? Okay. Now I'm gonna get the sum of the square of the deviations. We are going to add all those deviations together, all the yellow shading.
For the very last one, I got 188.2384. Am I correct? Or
The very last one, 10.7 minus 24.42. The difference is negative 13.72, right? And I raised to the power of, yeah, you are right. Oops, 188. Thank you for paying attention and being with me. 188.2384. Awesome, very good, thank you. Yeah, I have 188, and then when I copy, I copy 189. You wouldn't know that that would happen, so we need to be very careful. Okay, so I'm adding that. Now I'm on 242. So what's the sum you got? Is that same as yours? Yeah, let's see what's the chat. Is anyone else having connectivity issues? I have a good news to tell you. The first time we encounter this kind of problem, I would like you to try at least a couple questions that you use the formula to calculate the answer. And later I promise you, I will post the method, how to use TI-84 calculator to get it done faster. But the thing is, you use technology. The thing is, sometimes you use technology, you don't even understand the meaning of the concept. And that's not our purpose for learning this course. I got 1399, 1399. Oh my gosh. Should I do that again? I'm probably missing some values along the way. Okay, I'm gonna change to yours. 1399.376. This is also a way to know if you are paying attention, right? 1398.376. And then we're going to use that to divide by 9. Okay? And then if you have a good calculator, you are going to raise the value to the power of half. Depending on calculator, you can use square root, or you can simply raise the answer to the power of half. Same thing. And the square root, if I keep 2 decimal places, I get 12.47.
Did the 9 come from the n minus 1?
Yeah, correct. Thank you, Riley. Yeah. The sample size is 10. We have 10 values in the data set. N minus 1, 1 less than 10 is 9. That's how do we get it. All right. Yeah, as I said, I need to get a camera. Yeah, I have been thinking to make a video about how to use the calculator to get those done quickly. I need to get a camera first for that reason. Because if I hold my phone, the quality will not be good. It will be very blurry like all other shorts I made. So be patient. I'll get it done. I'll try to get it done as early as possible. So this is how do we manually use the formula to calculate the sample standard deviation. I got a 12.47. That value describes or measures the spread out, how those values spread out around the center. Okay, that's the standard deviation. Standard deviation is a very important concept. Any question about it? Any question about how do we get a value? When you watch, when you're taking the class, when we have some important concept, for example, my table formulas, what you can do is you can quickly take a picture. Nowadays, everybody has a phone, right? You quickly take a picture of those things and you can review later. This is the process. Okay, so that's how do we find the standard deviation, sample standard deviation. How do we find the sample variance? Number 3. Notation S square. We actually have the sample variance right here under the square root, right? Yeah, you don't have to go back the square. You can on your calculator, if you have a TI-84 calculator, you still have the history on the calculator. And S square is around equal to 155.49. When you work on your homework in this section about the rounding, just read the instruction of the question. The question will tell us how to round. Keep 1 decimal place or 2 decimal places. Just follow whatever the question asks you to follow. All right, so this is how do we find range, sample standard deviation, and sample variance by using a calculator and a formula. There's a faster way. You can use software, but I do not recommend because you will not have that available during the test. But you can also use the TI-84 calculator. There's many functions in it to get it done quickly. Yeah, waiting for my video. Any question about example 1, guys? Will we be able to use a scratch paper? Yes, for sure. For sure. The testing center will give you the scratch paper.
Also, the testing centers should have TI-84 calculators available. So if you don't have your own, they have them there.
Are you sure they have?
I talked to a math teacher and she said that they have assured her that they always have TI-84 calculators.
I would recommend you call the center in person and double check with that. confirm that. Even they only have a limited number of calculators. Doesn't mean you go there and they will guarantee you have one. So make sure you call them to confirm. All right. I know the tutoring center also has some calculator, but also limits the number of calculators. You can rent them for the day, but you can leave campus. You cannot. Okay, yeah, it's just on a daily basis. Okay. Okay, example 2. Example 2 is how do we estimate sample standard deviation if we are not given the raw data set. Instead, we are only given a grouped frequency distribution table. Example 1, we have the raw data set. It's a very small sample, just 10 values. And it's still very pretty time consuming get those done, right? Yeah, I did not time us how long it takes. This one, what if you do not have the raw data set? Instead, you only have a grouped frequency distribution table. This question is from MyLab Math. It's a question from section 3.2, number 11. Yeah. So you are given a grouped frequency distribution table. The first row, yeah, for some reason their distribution table is a horizontal. The first row gives you the range or classes. The first class from 30 to 36. Frequency is 2. That means in the data set, 2 values fall between 30 and 36. Second class, 37 to 43. We have 2 values fall there. And the next class, 44 to 50, we have 6 values fall in that range, and so on and so on and so on. The last class, 72 to 78, we have 34 values fall between that range. So that's how do we understand the grouped frequency distribution table. I hope you still remember that. Now, how are we gonna calculate the sample standard deviation manually? Yeah, use software, of course, is good, as I said, but you don't understand the reasoning, right? You don't understand the concept. That's not what we want. So the question gives us a formula. This formula is equivalent to the regular formula. Difference is you have a F in it. F is the frequency. I'm not going to prove this formula is equivalent to the regular one. We are going to just go ahead to apply it. All right. Yeah. So here, my idea is I'm going to highlight this part as pink. Okay. And I'm going to highlight this part as green. That's the 2 sums in the formula. So we are going to find the value for the pink and the value for the green separately, and then put them back to find the sample standard deviation. How do you think about that? And another thing is, simple, we do not have the raw data. We do not have exact the value for xi, I from 1 to n. We only have the range. So we need to find what? We need to find the middle point. If you still remember that. Okay? Yeah, tell me please, what's the middle point from of the first class? Lower limit is 30. We're here, guys. We're here. First class. Lower limit is 30. Upper limit is 36. How do we find the middle point of that class? Awesome. Thank you. The average of the 2 limits, right? Yeah, 33. I'm going to write 33 right here. Yeah, that's our middle point for the first class. Yeah, for the middle points of other classes, there's a trick. Let's find the class width. What's the class width? Not 6, by the way. not 6, not 1. 7. Oh, you probably enter wrong. It's 7, right? Again, class width is the distance between any two consecutive lower limits. The first lower limit is 30. The second lower limit is 37. The distance between them is 7. So the class width is 7. So we are going to add a 7, add a 7, add a 7, add a 7 to get the other middle points. 33 plus 7, 40 plus 7, plus another 7, plus another 7, plus another 7, plus another 7. Yeah, if you want, of course, you can just take the average of the two limits, right? Yeah, but this way I think is faster. Okay. All right, ready? We are going to do the pink now. The pink is the pink is the sum of the frequency times x. Again, x here is the frequency. I'm sorry, f is the frequency. X here is the middle point for each class. Luckily, we don't have many classes. How many classes we have? 1, 2, 3, 4, 5, 6, 7. Yeah, only 7. And then to the power of 2. Yeah, no power of 2. Oh, hold on. Yeah, so the pink is sigma f times x squared. Yeah, very good. So we're going to do this, okay? We are going to take the square of the first middle point and then multiply by the frequency plus second middle point to the power of 2 multiplied by the frequency plus 47 squared times 6. Yeah, let me know if you know what I'm talking about here. 54 squared times 3 plus 61 squared times 16 plus 68 squared times 36. If I wrote something wrong, please let me know. My brain doesn't work the best in the evening. 75 squared times 34. And then we add them up, right? Yeah, let's see what do we have here. You can use a calculator. And I'm gonna be silent for 1 minute and you tell me if what you have. It's a good practice for you to get familiar with your calculator. What do you have? Let me double check here. Oops, I made one mistake here. Yeah, anyone would like to share? Is yours same with mine? Oh, okay. Perfect. So that's the pink part, right? Yeah, that's the pink part. And now let's do the green part. The green part is also a sum. Sum of what? Sum of the frequency times the middle point. This time we don't need to get a square. Yeah, we only need to multiply the frequency with the we only need to multiply the middle point with the frequency and add them up. So 33 times 2 plus 40 times 2 plus 47 times 6 plus 54 times 3, 61 times 16, 68 times 36, 75 times 34. Give me a little time. I got a 6,564. 65, 64. Do you have the same thing? Yeah, from here, you know, even it's very important to have a good calculator that you feel comfortable to use. All right. Okay, now we have the difficult part, the summations taken care of. And I want you to tell me what is n. How many values in the sample? So here's a 10, and that is 19, 39, 39, 36, 75, 75 plus 34. What's your sample size? Not just a sample size. Sample size is not the number of classes. Okay, let's add all those frequencies together. That's how do we get a sample size, right? 2 plus 2, 4, 4 plus 6, 10. 10 plus 3 is 13. 13 plus 16 is 29. Am I right? Okay, 29 plus 36 plus 34. Do you have a 99? Ooh, 99, 112. This, okay, hold on. So that gives us, this gives us a 70, and this is a 10, and that is 19. So 29 plus 70. 99 is the right one. 99 is the right sample size, right? Yeah, 99 is the right sample size. Are we clear about how do we find the sample size? Just add up those frequencies. Add up those frequencies. Okay, thank you guys for following. Okay, What is crystal? Oh, okay, crystal clear. Okay, so now we're gonna plugging in the formula. S equals square root. Okay, so here we have 99 times the pink. The pink is 444630 minus square of the green, so 6564 square, and all over 99 times 98. Okay, so let's use a calculator to get it taken care of. I'm going to do the numerator first. 99 times 444630 minus 6564 to the power 2. And that's the numerator. And then divided by 99 times 98. And then I'm going to raise to the power of half. I get a 9.80259 something something. So if we keep one decimal places, we have 9.8. 9.8. Do you have the same thing, guys? Hello? Are you with me? Everybody, do you have the same value, the result, 9.8? Oh, it takes time. Okay, very good. Yes, 9.8, exactly. On your calculator, you have TI-84 calculator. I'm not familiar with other type of calculator. Once you have the quotient, you raise to the power half. Parentheses, 1/2, close the parentheses. Or you do this, 1 divided by 2. And you would have the square root. All right. I really hope that I have the camera that I can show you when I'm using calculator, but my device doesn't support that. It's very not convenient. If I use a rare camera, I have to embrace my laptop. I tried that, it's not feeling very comfortable. All right, guys, are we good with this question? And I'm gonna show you something. Use the StatCrunch. I hope you do not hate me. Why do we need to do that manually when we have the software? Because
so I have a question for like the test. Are you going to just ask for the answer, or are you going to like ask us to see sort of our process?
That's a very good question. The questions on your test would come from the same pool with the questions on your assignments and the quizzes. You see what I'm talking about? So the questions you are practicing every day from the assignments, those are the type of question you will see on the test. They are from the same pool, the same question bank. Did I answer your question?
Somewhat, but I guess my question was relating to the fact that like you could sort of kind of see the process. So even if we got a number wrong in one place, you would see how it looks. It sounds like no, that's not how the test is going to appear.
How did you do your assignment? If you mess up one value, the system give you partial credit only, right? If you didn't get it completely right. Same with all the assignments questions. It maybe just one cell, maybe it has multiple parts of the question. You should be able to see the study guide for the test 1 And the questions on the test 1 should be very similar with the questions on the study guide. Is that better?
I had a question as well. Whenever we take the tests, are we going to have like any kind of like formula sheet or anything that we're allowed to bring?
That's a very good question. Based on syllabus, is it close book, close no? So when you practice, you try to memorize the answers. Also, I'm going to, as I said, going to make the videos to show you how do we use the TI-84 calculator. I tried to download the emulator on my, as you can see here, on my computer, my personal device, but it requires license. I'm not able to use it. So I want to use my actual physical calculator to show you. No, you don't have a formula sheet. You probably won't need it once you know the TI-84 calculator way. Something like that. For example, this question, they give you the formula, right? Do you need a formula for sample mean? I don't think so.
So I'm not able to access that because I haven't completed 3.1.
That's a scientific calculator.
No, excuse me. The work that you're working on right now in chapter 3, part 2, yeah. I'm not able to access that question 11 because I haven't completed 3.1 or 3-1.
I think my answer actually quite my response answer your questions. I said questions on test 1 are from the same pool with the questions on assignments. They are the same type of questions. Probably the same.
Yes, no, sorry, I was asking or sort of stating something different. Because you're in homework 3-2, measures of variation, we can only access that if we have completed 3-1, measures of center. So I was just letting you know that I can't access the data that you're currently working with.
Oh,
does that make sense?
Yeah, but let me show you how you only spend seconds to get this problem done, okay?
Okay.
Just don't hate me because we spend so much time to do this manually. Yeah. Okay, you see the small thing and click that. Open in StatCrunch. What we are given is not a raw data set. What we are given is a grouped frequency distribution table, right? So when this is still loading, what happened?
I have a question also. For the tests, how long do we have? Because like for the last section, there was like a question that had like 50 you know, like data that you had to like put in order and stuff like that. And that took me, I would say like 15 minutes to organize it all.
I understand. Yeah, let me check for you, okay? Yeah. I remember I posted a announcement that is actually also for a note for myself. I remember there's only 20 questions. Let me see the Blackboard. Let me see if I can go there. Not all the questions time consuming, maybe just a few. Majority of other questions are very, you can get it done very fast. This one. Yeah, the latest post. A note about exam 1. Yeah, 20 questions. We only have 20 questions, and you ask the time for exam 1. Let me show you. I'll just look at it here. Assignments. I'm not sure if you can see on your end. You probably could. Exam 1. That's quiz. Quiz 60 minutes. Exam 1. I don't know why it keep kicking me out. This is the shell. I want to go back your class. Here. Here. Some questions like that, I prefer you ask me by shooting me an email, because really time consuming to check during the class when we have so many things open while recording everything.
I looked on here and it shows like an hour and 50 minutes is what I think you posted on your syllabus.
Okay, awesome. So 1 hour and 50 minutes. So the exam. So you can yeah, 120 minutes. No, hold on. Exam 1. I'm sorry. Exam 1. So oh, okay. I did not have the. Let's see.
I looked under the exam information tab right there to the left, and it had all the exam information.
No, that's from the previous classes. I think at least 100 minutes, okay? Yeah, whatever the minutes, you have enough. Don't worry about the time. You have enough time. I will check. If you email me, I'll check later. Can we check that later, please? Some questions like that, I prefer you email me. Let's go back to question number 11. Yeah, thank you, Melinda. Because too many webs, like too many pages open, everything, it's just slow down the process. Okay, let's look at number 11. Let me show you how do you use the software. Then you don't suffer when you when you do the homework here. So open StatCrunch. Even you do not see on your end, you can see what I'm doing here. And maybe you write down the steps, or later you watch the recording of the class. Okay, finally, perfect. So it's very small. You go to Stat, S-T-A-T. You would have a drop-down menu, right? And the second item is Summary Stats. And when you point to Summary Stats, you will have another drop-down menu on the right. And you are going to click the last one, Grouped Data, okay? Grouped Data here. And your bins, your classes are those intervals. Yeah, from 30 to 36, that's first class. 37 to 43, that's second class. So your classes are those intervals, and your counts are the frequencies. All right, and take care of those two things. And then we are going to, do you see the gray area? You are going to click standard deviation. Once you click that, only the standard deviation is gray and it will show up, will be added to the right hand side here, standard deviation. Okay, and then you are going to compute. What do you see here? I said a few seconds, right? You are able to get it done in a few seconds. $9.802591, same with ours. Okay, yeah. But as I said, I do not, this one is time consuming, so I'll show you a little bit. But the purpose of taking this class is you also know how to manually calculate the result by using the formulas. That's one of the important purposes. Okay. And then, okay, so we're gonna keep going now. The next thing is two theorems about variation, about how do we estimate variation. We need to know the two theorems. The first theorem is called the range rule of thumb. When you work on your homework, you'll see that a lot. Range rule of thumb. Okay? Yeah. How do we use, when do we use range rule of thumb? We can use range rule of thumb for three different things. The first thing, if we know the range of the data set, question, what's the formula for finding the range of the data set? That's the first thing we learned today, right? How do we find the range? Where is this? Is maximum minus minimum, right? Okay. So the first thing is, if we are given a range of the data set, we are able to approximate the sample standard deviation. How? We simply divide the range by 4. Then the result would be an approximation of the standard deviation. That's the first thing. Because we assume a majority of the values fall between 2 standard deviation away from the center. That's how do we do that. Majority of values fall within 2 standard deviations of the center. So the first thing we can do by using the range rule of thumb is to estimate standard deviation by using the given range. And the second thing we can do is we are going to transform this equation. Actually, it's not exactly equation. Yeah, we are able to estimate the range if we have the standard deviation given. If we know the standard deviation, we multiply by 4, then we know the approximation of the range. So we know the variation, right? Yeah, basically the range is around 4 times of the standard deviation. That's the second thing we can do by using the range rule of thumb. The third thing we use the range rule of thumb is to decide a specific value. Yeah, we consider if a specific value in the data set significantly high or significantly low. Okay, yeah, how do we know that? So this is mu. Mu is the population mean. We can actually totally change that to x bar, sample mean, because when you look at the homework, all about samples. And here is a sample mean plus 2s. This is sample mean minus 2s. So the orange region in the middle, those values are within 2 standard deviations of the center. If your specific value, this guy, if your specific value follow the orange range, then your value is not significant. It's not significant. But if your value is more than, equal to, or more than sample mean plus 2s, then your value is significantly high. If your value fall lower than, equal to or lower than x bar mean minus 2 standard deviation, then your value is significantly low. That's the third thing we can do to determine that, to use the range rule of thumb. Does that make sense, everybody? Yeah, when you work on your homework, you can review, you can refer to this graph, the 3 things. You can take a quick picture. Everybody has a phone, right? Even I do not post my note, you can totally get it done by taking pictures. All right? Any question about range rule of thumb? Range rule of thumb just approximate, assume majority of the value fall within 2 standard deviations of the center. And this rule applies to any distribution. Any distribution. Question about range rule of thumb. I have some questions about applying those rules, but we probably don't have the time for that. And the second rule is called the empirical rule. Empirical rule only apply to a data set that is normally distributed, or at least roughly normally distributed. Okay, yeah, what it says. This rule is also called 68, 95, and 99.7 rule. Yeah, remember the 3 numbers. Empirical rule tells us if we have a data set that is normally distributed or roughly normally distributed, we have approximately about 68% of the value fall between 1 standard deviation from the center. So from x bar minus s to x bar plus s. We have 68% values fall there. And we have around 95% fall between x bar minus 2s and x bar plus 2s. That part is consistent with the range rule of thumb. And we have 99.7%, almost all the values, fall within 3 standard deviations from the mean. So x bar minus 3s to x bar plus 3s. I'm using the interval notation. Yeah, this graph shows you the 68, 95, 99.7 rule. Is also called the empirical rule. Very important is empirical rule only applies to normal distribution. Yeah, later we have the whole chapter talking about normal distribution. Yeah, majority, this section, around 68% fall here. Okay, yeah, from x bar to minus s to x bar plus s, and around 95% fall within here. 95% fall within 2 standard deviation away from the center. And almost all, 99, let me use a different color. Do I have a blue? 99.7%. Almost all of them fall between x bar minus 3s to x bar plus 3s. We run out of time. We do not really have time to practice those questions that are related to the 2 rules, but they are not difficult. They are not difficult. Majority of today, we focus on how to compute standard deviation, range, standard deviation, and variance, right? Using the formulas. I think we get the most important thing covered. Yeah, again, waiting for my video, okay? Waiting for my video. There's an easier way to do that, to do those things. Do you guys have any questions about today? Nope. Thank you, Riley. I hope nobody have left yet because I'm taking attendance by taking a picture. If you have already left, then you lose the attendance point for today. All right, I think that's all for today. If you have any questions, feel free to email me. The communication of the online live class isn't the best. Sometimes I feel a little frustrated because I don't see you, I don't hear you, I don't know if you are following or as I complete the homework, but nothing for now. Okay, thank you, Kelly. Yeah, you guys have a great night too. See you on Thursday. We do not meet on Tuesday, okay? I'm going to see you on Thursday. See you guys on Thursday. Bye-bye.